Second example, I am taking f is from r minus 5 by 2 to r minus 1, defined by fx is equal to 2x minus 7 by 2x minus 5. Prove that this function is 1 1. Okay? Then you can try also. Let f of x1 is equal to f of x2. First I will write this and simplify, and if it gives x1 is equal to x2, that means function is 1 1, where x1 x2 are from this set. F of x is how much? F of x is this, then f of x1 will be equal to 2x1 minus 7 by 2x minus 5. F of x2 will be 2x2 minus 7 by 2x2 minus 5. Then first cross multiply 2x1 into this, 4x1 x2 minus 10x1 minus 14x2 minus 7 into this plus 35, and here x1 take 2x1 into this, 4x1 x2 minus 14x1 minus 10x2 plus 35. I can cancel 35 from both sides, this term, and if I will take x1 and x2 on the different side, x1 I am taking this side, so minus 14x1 will come here, then it will be 4x1. Here minus 10x1, it is minus 14x1. It will be 4x1. I will take this term to this side, again 4x2. That means what? x1 is equal to x2, and this function is 1 1 function. Now, I am taking third example in which I will prove by this method function is many one. Okay. Just take example. Suppose f is r to r and fx is x by 1 plus x square. For this function, I think method 1 will be more difficult. Here, to guess the values at which value of function is same becomes more difficult. Okay. But this method I can use, or I can guess also if I try. Okay. So what I'll do, I will equate f of prove that function is many one. I will equate f of x1 is equal to f of x2. F of x1 is how much? x1 by 1 plus x1 square. F of x2 will be x2 by 1 plus x2 square. Then cross multiply x1 plus x1 x2 square is equal to x2 plus x1 square x2. I will take all terms in one side, and there must be x1 minus x2 common factor. Remember, x1 x2 from these two terms I can take x1 x2 common. x2 minus x1 is equal to 0. That means I can take x1 minus x2 as a common factor. Remaining factor will be 1 minus x1 x2. Okay. Product of these two factors is 0. That means what? Either one factor is 0, first factor is 0, or second factor is 0. That means 1 is equal to x1 x2. This is 0. That means 1 is equal to x1 x2, and this gives x1 is equal to x2 or x1 x2 is equal to 1. For this we have no problem. Many one function also has two different gives same value at same number. It is no problem. But this extra second factor 1 minus x1 x2, this factor may create difficult, may create problems for one function. If it gives two different numbers which will satisfy this equation and which lies also in the domain, then function will be function will be many one. Sorry. Our domain is R. Okay, I am taking example x1 is equal to 2 and x2 is equal to 1 by 2. These two values will satisfy this equation, and these two are the different numbers, also belongs to the domain part. So that means what? F of 2 is equal to f of half. Because if this is the condition, then again f of x1 is equal to f of x2. That means at these two numbers function value is same. That means function is many one. Okay? Are you getting? You can try on other questions. Okay. Next, method 3. And method 3 and method 4 I can use in competition point of view. Okay. Method 3 we must know the graph of the function, because we are studying the horizontal line test. Horizontal line test is for to decide one or many one function. Okay. Write down the statement. If there exists at least one horizontal line means line parallel to x-axis. If there exists at least one horizontal line which can intersect the graph at more than one point, that means function is many one. Okay? If I draw all possible way horizontal line, but there is no even a single line which can intersect graph of function at more than one point, that means function is 1. Suppose I am taking example, f is R to R, fx is equal to sin x. For this method I must know the graph. So this function will be used only when if I can draw the graph. Okay. For those functions I can use this method. If I draw the graph of sin x in entire number line, because domain is R, graph will be this. I can see that here there are infinite lines possible which can cut the graph at infinite points, means more than one point. That means function is many one. Okay. Second example, fx is equal to e की power x, and same domain is R. F is from R to R. Because I know the graph of e की power x, then I can use this method. Graph of exponential function is this. Okay. See whether this function is 1 or many one. I am drawing all possible ways the horizontal lines. All possible ways, draw all the lines which are possible, horizontal lines. Whatever, take so much effort to draw the horizontal line. See, I can see here the no line intersect at more than one point. Okay? Every line intersect at single point only. That means function is 1. This is 1 function. Okay? Are you getting? Now, method is 4. Method 4, I can use this method only when I know the differentiation part. So, if we know the differentiation, then this method can be used. And this is the last method, ultimate method. And by this method, we can try the difficult to difficult questions. Okay. What is the method? You can write the statement if f dash x greater than or equal to 0 for all x belongs to the domain of the function. Means sign of f dash x is positive for all x belongs to domain. Entire domain f dash x is positive. Or if f dash x less than 0 for all x belongs to domain. in f dash may be less than 0, but for entire domain. That means in the entire domain, sign of f dash remains the same. Then function is 1, 1. In both cases, function will be 1, 1. But if sign of f dash changes inside the domain, then function will be many 1. F dash x may be 0, maybe, but at discrete points. Okay? F dash x may be 0, but at discrete points. Means what? If I solve f dash x is equal to 0, then we should not have the solution as an interval. In interval, this should not be 0. In discrete point, it can be 0. That means at infinite points, whatever points are possible, whether it is infinite. Suppose f dash x, f dash 1, 0, f dash 2, 0, f dash 3, 0, but f dash 4, 0, and so up to infinity. Again, again this function is 1, 1. Because between 1 and 2, there are gaps. F dash 1 is 0, f dash 2 is 0. 1 and 2, there are gaps. In gaps, we are having the numbers at which value of function is 0. That means not forming an interval. Then function will be 1, 1. Okay? I'll just try one example only. Suppose f r to r, fx is equal to x cube minus 5x plus 6, plus I am taking plus sign. See, find whether f is 1, 1 or many 1. Okay. I have to calculate for this f dash x. F dash is how much? 3x squared plus 5. See, this expression, this term will be always positive for entire number, entire real number. This will be non-negative. So f dash x must be greater than equal to even 5. Means greater than equal to 0 for all x belongs to the R, which is the domain part. So it is, f is 1, 1 function. Okay, are you getting? So at this point I am concluding my lecture. Thank you.